Hi everybody. Let's start with the first chapter, lines and angles. Before starting with lines and angles, let us understand the origin of geometry in short. The word geometry is the combination of geo and metron, where the word geo stands for earth and metron stands for measuring. The ancient people of different countries like India, Egypt, and Greece had come up with numerous geometric properties. Simple of the properties that we accept as true are called as axioms or postulates. These postulates mainly deal with the point, line, and plane. Let us draw a point. Now, when we draw multiple such points, we will get a line. Therefore, a line is called as a set of infinite number of points, and multiple lines together form a plane. Let's discuss Euclid's 5 postulates. Postulates are the terms used for the assumptions that were specific to geometry. First, a straight line can be drawn from any point to any other point. This postulate simply says that if you have any 2 points, say A and B, then you can always connect them with a straight line. Second, a terminated line can be produced indefinitely. It tells us that we can always make a line segment longer. That means we never run out of space, that is, space is infinite. Third, a circle can be drawn with any center and any radius. It allows for the existence of circles of any size and center, say center A and radius AB. Number 4, all right angles are equal to one another. Whenever we create a right angle by erecting perpendiculars, the angles so created are always the same. Number 5, for every line L and for every point P not lying on L, there exists a unique line M passing through point P and parallel to L. It is very clear that there is something quite different about this 5th postulate, even hard to read and understand. Make the interior angles on the same side less than 2 right angles. The 2 straight lines, if produced indefinitely, meet on that side on which are the angles less than the 2 right angles. Now, let us discuss some axioms. 1. Infinitely many lines can be drawn through a given point. For example, point P is given, line L, line M, and line L pass through the point P. Second, there is one and only one line passing through 2 distinct points. Say, a line passing through the points A and B is denoted by line AB or line BA. Here, 2 distinct points do not determine more than one line. That is, the line is unique. Number 3, when 2 distinct lines intersect, their intersection is exactly 1 point. In this figure, line L and line M intersect in point P. 4. There is exactly one plane passing through 3 non-collinear points. For example, here A, B, C are 3 non-collinear points. Plane E passes through these points. Number 5. There is exactly one plane passing through a line and a point, not on the line. Plane E is determined by a line L and the point P, which is outside the line. Number 6. There is exactly one plane that passes through 2 distinct intersecting lines. Here, line L and line M are intersecting in point P. Plane E passes through these intersecting lines. Number 7. When 2 planes intersect, their intersection is exactly one line. Here, the planes P and Q are intersecting each other. Line AB is the intersection of these planes. Number 8. When a line intersects a plane but does not lie in it, then their intersection is a point. Line L intersects the plane E in point P. 9. A line containing two given points of a plane lies wholly in that plane. Now, let us discuss some other terms. Collinear points. 3 or more points are said to be collinear if they lie on a single straight line. Non-collinear points. Points that do not lie on a single line are called as non-collinear points. Concurrent lines. A set of lines or curves are said to be concurrent if they all intersect at the same point. The point is called the point of concurrency. Parallel lines. Lines in a plane which do not meet, that is, two lines in a plane that do not intersect or touch each other at any point are said to be parallel. Parallel planes. Parallel planes are two planes that do not intersect. Thank you for watching. Hello students. Now let us understand coordinates of points and distance. As we know, we can represent any number by a point on a line uniquely. For example, here coordinate of D is -8, coordinate of A is -4, coordinate of B is 1, and coordinate of C is 6. Distance between A and B is 5, which can be denoted as D of A and B, and can be calculated by D of A and B is equal to x minus y, where x is the coordinate of A and y is the coordinate of B. As we know, distance between 2 points cannot be negative, therefore we will take the modules. Betweenness. There exists a relation of betweenness among three distinct points. If point P, Q and R are three distinct collinear points, and if distance of PQ plus distance of QR is equal to distance of PR, then the same point Q is said to be between the points P and R. We write PQR, which is same as RQP. If distance of PR plus distance of RQ is equal to distance of PQ, then PRQ. If distance of QP plus distance of PR is equal to distance of QR, then QPR. Thank you for watching. Hello students. Now let's learn segment and ray. Line segment. The set consisting of points A and B and all the points between A and B is called the segment AB and is written as segment AB. Segment AB and segment BA denote the same line segment since both contain the same set of points. The points A and B are called the end points of the segment AB. A line segment is a subset of a line. Length of a segment. The distance between the end points of a line segment is called the length of the segment. The length of segment AB is denoted by length of AB. Since we denote the distance between the points A and B by distance AB, we have length AB is equal to distance AB. We denote length AB as AB, so AB is equal to length AB is equal to distance AB. Congruent segments. Two line segments are said to be congruent if they are of the same length. If length AB is equal to length CD, then we write segment AB is congruent to segment CD. Properties of congruent segments. 1. Reflexivity. Every segment is congruent to itself. Segment AB is congruent to segment AB. Number 2. Symmetry. If first segment is congruent to a second, then the second segment is congruent to the first. If segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Third, transitivity. If first segment is congruent to a second and the second segment is congruent to the third, then first segment is congruent to the third. If segment AB is congruent to segment CD and segment CD is congruent to segment PQ, then segment AB is congruent to segment PQ. Midpoint of a segment. The point M is said to be the midpoint of segment AB if AMB and distance AM is equal to distance MB. Every line segment has one and only one midpoint. Here, segment AM is congruent to segment BM. Comparison of segments. Suppose segment AB and CD are given. If length AB is less than length CD, then we say that segment AB is smaller than segment CD and denoted by segment AB is less than segment CD. This also means that segment CD is greater than segment AB. Ray. Suppose A and B are 2 points, then set of all points of segment AB together with all the points P on the line AB for which P is between A and P is called the ray AB. The point A is called the origin of ray AB. The ray is a subset of a line. Segment AB is a subset of ray AB. Opposite rays. Two rays which lie on a line having same origin are called opposite rays. In the figure, ray AB and ray AC are opposite rays. The origin A is common point of ray AB and ray AC. Thank you for watching. Hello students, let's learn plane separation axiom and angles. Plane separation axiom. Given a line in a plane, the points in a plane that do not lie on the line form two disjoint sets H1 and H2. Each set, H1 and H2, is called a half plane and the line is called the edge of the half plane. If P is a point in any of the half plane, then that half plane is called as P side of the half plane.